All right, here we go. So lesson number 10 is a little review of polynomial division and complex numbers. So again, these are all kind of topics. A lot of chapter 2 is a little bit of review of algebra 2. All right, so if you remember, we talked about the division algorithm before. So the division algorithm basically tells you that any number is equal to the divisor times the quotient plus the remainder. Okay, and the same is true for polynomials. So if you divide 322 by 12, you get 322 is equal to 12, which is the divisor, times the quotient, so the number on the top of the division sign, so 310, plus the remainder of 2. Okay. Sometimes I ask you to write things in fraction form, which would be 310 and 2 out of 12, or 310 and 1/6. Okay, so when we divide polynomials with division, your fave, we do it kind of the same way. So I always tell you that if you're missing any like x squared or x terms or whatever, put them in. So see how this one starts with x cubed? But then it goes down to the number and it skips over x squared. See how it goes x cubed, there's no x squared term, x, and then the number. So since we're missing an x squared, we're going to put in a 0x squared. So we're going to have x cubed plus 0x squared plus 6x plus 3. And we're dividing by something that starts with x squared, so we want to make sure it goes all the way down. So x squared, x terms number. Okay. So I have x squared minus 2x plus 2. Has everybody done this before? Anybody from other schools that has not done this before? All right, so what I always tell you is to look at the very first item, the x squared. And what you say is how many times or what do I multiply x squared by in order to get the x cubed? So x squared times what gives me x cubed? X. So I put an x on the very top. Okay, so then I take the x and I multiply by all three things in the divisor. So when I do x times x squared, I get the x cubed that I wanted. X times negative 2x is negative 2x squared. X times 2 is 2x. And I always say, do you guys remember? Draw the line, change the signs. So you don't forget that you're subtracting out that entire polynomial. So if I'm changing all the signs and then I add straight down, it's the same. So when I add straight down, the x cubes go away. They should always go away. That first item should always go away. Now I get plus 2x squared, and then I get plus 4x. Okay, so now I repeat the process. So it's like I'm starting over, and now I have my divisor, or my dividend is the 4x squared, or 2x squared plus 4x, and then my divisor is x squared minus 2x plus 2. But we don't write that. We don't write it off to the side as a new function. Okay, we always drop the plus 3, and then we start it over again. So now we're saying, what do I multiply x squared by in order to get 2x squared? So I need a plus 2, exactly. So I'm going to do plus 2. And now I take that 2 and I multiply by everything. So I'm going to have 2x squared minus 4x plus 4. Draw the line, change the signs. Okay. All right, so now when I add straight down, my 2x squareds go away. I get 8x minus 1. That is my remainder. Because I can't repeat the process. I can't say, what do I multiply x squared by in order to get an 8x? I don't do fractions. Okay, so that's as far as I go. Okay, so if I write it in that form, the p of x equals d of x times q of x plus r of x, my p of x is the original polynomial that I was dividing. So I was dividing x cubed plus 6x plus 3. The divisor is what I was dividing by. So I was dividing by x squared minus 2x plus 2. My quotient is the thing on top, x plus 2. And my remainder, so I'm just going to have plus on the end, 8x minus 1. And the nice thing about these is if you have lots of time on your test at the very end, what you can do is you can check it. So you could just multiply it all out. Yes? The p of x, d of x, q of x. Yeah, so it makes more sense if you look at this one. If I divide 372 by 12, so let me quickly do that. So I get 310, it doesn't go in any more times, remainder of 2. All right, so I have 310 remainder of 2. So what that means is that the original, this is called the dividend. I just remember it's the big word, it's usually big number or big polynomial, equals the divisor, which was 12, so it was the number I divided by, times 310. And if you multiply those together, you end up getting 3,720 if you multiply those. So your remainder was 2. Okay, so it's always set up that way. So dividend, divisor, quotient, and then remainder. Okay, running out of room. The quotient remainder. Does that make sense? So it's the same idea here. So the dividend was this part on the inside. The divisor was what I divided by. The quotient was up here, and the remainder was here. All right, does that make more sense? Okay. All right, so same idea here. So it says find x squared minus 3x cubed plus 4x squared minus 9 and divide by x squared minus 2. All right, so we're going to set it up the same way. So I have x to the fourth. I have an x cubed term. I have an x squared term. Notice how I'm missing an x term, so I put plus 0x minus 9. All right, and then when I write the divisor, I have x squared, but then I'm missing an x term, right? So I'm going to put plus 0x minus 2. All right, so I say, what do I multiply x squared by in order to get x to the fourth? Okay, so x squared times what gives me x to the fourth? Okay, x squared. So I take that x squared and I multiply by everything in the divisor. So I'm going to do x squared times x squared is x to the fourth. X squared times 0x is 0x cubed. X squared times negative 2 is negative 2x squared. Okay, and I draw the line, change the signs, and add straight down. So my x to the fourths go away. I get negative 3x cubed plus 6x squared, and I drop my next term, plus 0x. All right, and I repeat the process. So it's now like this is my new dividend. So I say, what do I multiply x squared by in order to get the negative 3x cubed? Right, so I multiply it by negative 3x. So I take the negative 3x and I multiply by everything in the divisor. So I have negative 3x times x squared is negative 3x cubed. Negative 3x times 0x is plus 0x squared. Negative 3x times negative 2 is plus 6x. And I draw the line, change the signs. So when I add straight down, the x cubes go away. I get 6x squared minus 6x. And I drop the minus 9. So one last time. So I say, what do I multiply x squared by in order to get 6x squared? So 6. So I take the 6 and I multiply by each thing. So 6 times x squared is 6x squared. 6 times 0x is 0x. 6 times negative 2 is negative 12. Draw the line, change the signs. Add straight down. So I get negative 6x plus 3. That is the remainder. Yes?
Why didn't you drop the minus 9 the first time?
I only drop enough terms. So he's saying, why didn't I drop the negative 9 like right here?
Yeah.
I only drop enough terms, like I have 3 there and I have 3 here, so that they will line up, okay? Just like on your regular division, like these numbers, like we only did 36, right? We didn't drop all of them. And then we dropped the first 2, but not the second 2. All right. All right, so if I write this in fraction form, the fraction form is always the quotient plus remainder over divisor. And that's how it was for the 372 one, or 3722 one. So when you did 3722 divided by 12, you got 310, which was the quotient, and then you had 2 left out of the 12, right? So we had 2 left out of the original 12. Right, so that's what we're doing here. So we're saying quotient was x squared minus 3x plus 6. And the remainder was negative 6x plus 3 all over the divisor, which was x squared minus 2. So that's our answer. It's all kind of coming back. I know a lot of you guys weren't fans in Algebra 2. Do you remember there was another form of division? Synthetic. Now, what were the rules with synthetic division, though? It had to be like x, right? X the first. So you can't do it with x squared, x cubed, anything like that. It had to be x the first, and it had to be like x minus a number or x plus a number, right? All right, so let's try this. So divide using synthetic division. So if you remember synthetic division, we put the numbers from the dividend. So we do 1, -5, and 4. And then in the backwards L, we put the 0 of the divisor. So I'm going to put 3 there instead of negative 3. So it's like what if I set x minus 3 equal to 0 and I solved, I would get x equals 3. Basically, we do that because, do you remember in the long division how we changed all the signs? I always said draw the line, change the sign, or yeah, draw the line, change the sign. And we added straight down. Synthetic division is always adding. This is where you change the sign. Okay, does that kind of make sense? All right, so I'm going to drop the first thing, 1. So always drop that first term. And then I take 3 times the 1 and I put it here. Okay, so I'm going to have 3 times 1 is 3. And then I add straight down, so I get negative 2. 3 times negative 2 is negative 6, and I add straight down, I get negative 2. All right, so this is a shorthand method. It doesn't have any x's in it. So now we think about what the x's are. So when we have this 1 and minus 2, what that represents is a quotient of x, 1x, minus 2. And our remainder is negative 2.
It's not x plus 2.
Mm-hmm. So our p of x is going to be x squared minus 5x plus 4. Our d of x was what we divided by, which was x minus 3. Our quotient was x minus 2, and our remainder was minus 2. So if you check, if you FOIL it out, you get x squared minus 5x plus 6 minus 2 gives you the plus 4, like you wanted. So you can check. You can multiply it out quickly, and you get it.
Are we going to have to put it in that UD form?
It depends on what I ask for, yeah.
Okay.
All right, so next one. So divide x cubed minus 27 by x minus 3. All right, this is actually a cool way to actually factor x cubed minus 27. So a lot of you guys have forgotten your sum and difference of 2 cubes. You can actually use synthetic division to do it. So if you have x cubed minus 27, that's 1x cubed, 0x squared, 0x minus 27. And we're dividing by x minus 3, so we put a 3 in the backwards L. And we drop the 1. 3 times 1 is 3, add straight down, I get 3. 3 times 3 is 9, add straight down, I get 9. 3 times 9 is 27, add straight down, I get 0. So when we have a remainder of 0, that means that it factored, right? So what we have is x cubed minus 27 equals our divisor, which was x minus 3, times x squared plus 3x plus 9. That's how to factor the sum of 2 cubes, or the difference of 2 cubes, right? That's how we did it. Yeah. No. So if I had like x plus 3 there, then I would put a negative 3. Yeah. So it's always just the opposite of what you had before. I always say it's the 0 the divisor, meaning if you set it equal to 0 and solve, you get x equals 3. That makes sense. Yeah.
When does synthetic division work and not work? It only works when you have.
Oh, when are you allowed to use synthetic division? You can only use synthetic division if you're dividing by something that's x to the first power. Okay. But I wouldn't use it if you have like a divisor that's 4x minus 1 or something like that, because it gets kind of messy. It's not fun to do that. We've done that before, but. All right, so do you guys remember what I'm talking about, like factoring, like the sum of 2 cubes, difference of 2 cubes? Like if I had x cubed plus 64, that's going to be x cubed plus 4 cubed. So it would factor into x plus 4 times x squared, multiply the 2 together, so 4x plus 16 at the end. And your signs are same, opposite, always positive. Do you remember that? Okay. Do you see how synthetic division can help you with that? Yeah, basically you're saying, okay, well I know that x plus 4 goes into it, so I'm going to put a negative 4 in the backwards L. And then you can get the factorization by doing synthetic division. So it's kind of handy. All right, anyway, so the next one. So try to solve the equation x squared plus 1 equals 0. So I get x squared equals negative 1. I take the square root of both sides and write plus or minus. So what do we get? Plus or minus? I. So here's our little quick review of complex numbers. So remember, I is equal to the square root of negative 1. So what is I squared? Negative 1. What is I cubed? What's the simplest way to write that? It's I squared times I, so it's negative 1 times I, so we write negative I, and then I to the 4th. What's I to the 4th? 1. It's 1, because it's negative 1 times negative 1. It's I squared times I squared, which was negative 1 times negative 1, which is 1.
The pattern continues,
Yep,
right?
it continues that pattern. So it's always going to go I, negative 1, negative I.
So if you ask
Or not I, 1.
I to the 570.
Exactly, which you know I will, right?
Why did I even bring it?
All right, so find the zeros of f of x equals x squared plus 4x plus 12 by using the quadratic formula. So it's probably going to have i's. All right, so we're going to do x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. If you don't have the quadratic formula memorized, you should probably memorize that. Probably have it to some kind of cheesy song. All right, so I get negative 4 plus or minus the square root of 16 minus 48 all over 2. So I get negative 4 plus or minus the square root of what? Negative 32.
So isn't that 4 negative 3? 4 square root?
Ah, there's an I in there somewhere.
4i negative square root? 4i square root of 3?
Nope. Square root of 2, yeah. So negative 4 plus or minus. Shh, guys, quit talking. So square root of 32, the biggest perfect square that goes into it is 16. So if I have square root of 16 and square root of 2, I'm going to get 4 root 2. So if I have negative 32 under there, it's going to be 4i root 2 all over 2. All right, then we remember that the 2 goes into both pieces. I always draw a cheesy heart. The 2 goes into both. So we're going to have negative 4 divided by 2 is negative 2. 4 divided by 2 is 2. And the root 2 is connected to that. It's kind of like 4x divided by 2 is still 2x. You don't divide the root 2 by anything. So that's our answer. All right, next up. The complex conjugate. Who can tell me what the complex conjugate means? No, it's not fatness. If I have 5 plus 7i, what's its complex conjugate? 5 minus 7i, that's right. So it says the complex conjugate of any complex number, a plus bi, denoted by a plus bi bar. That's like a line above it. We call that a plus bi bar. Is just a minus bi. Okay, that's the complex conjugate. So when do we use this? We use it when we are dividing by complex numbers. Okay. So the first one, so if I have 3 minus 7i times negative 3 plus 4i, this should be very, very simple for you. So you're going to FOIL it out. So you get negative 9, you get plus 12i, plus 21i, minus 28i squared. A lot of people forget the I squared. But what was I squared? Negative 1. So you're going to have negative 9 plus 33i minus 28 times negative 1. So we're going to have plus 28.
So,
So what do we get?
33i plus 19.
19 plus 33i. Okay, so I always have you write it in what we call a plus bi form. So later on in pre-calc, we're going to be graphing complex numbers. We're going to be doing tons of stuff with complex numbers. It's going to be very fun. But the way that we graph them is we have a real axis and an imaginary axis. So if I wanted to graph 19 plus 33i, I graph it as 19, comma 33. It would go up here. It has a real part and an imaginary part. It's basically like the x and the y coordinate. Okay, so that's why I want you to write it like that. All right, so the next one is just addition. So that's really easy. So we just get negative 12 plus 13i. Okay, now we have 4 divided by 6 minus I. So we can't tell what the real part and the imaginary part is. So if I was asking you to graph it, you would have no idea how to graph it. So this is why we multiply by the complex conjugate. So we're going to multiply, instead of doing 6 minus I, we're going to multiply by 6 plus I on the top and bottom. Okay, so on the top, I'm going to get 24 plus 4i. And on the bottom, when I FOIL it out, only the first and last terms remain. The outer and inner end up canceling, right? So I get 36. The outer was 6i, and the inner was negative 6i, so those go away. Then I get minus I squared.
So
36 minus a negative 1, right? That was negative 1. So I get 37 on the bottom. So I'm still not totally done because I want to see what the x value is and the y value is if I was graphing it. Okay, so it would actually be 24 over 37 plus 4 over 37i. Okay, so you got to bring the 37 into both pieces.
why can't things ever be simple?
All right, so the next one. So what are we going to multiply by? Top and bottom? Yeah? Yeah, you can leave that I with the 4. That's fine. All right, so what am I going to multiply on the top and bottom by?
3 minus 4i.
3 minus 4i, right. That's the complex conjugate. So 3 minus 4i. You just want it to be like set up so it's like the difference of 2 squares on the bottom. All right, so on the top, I'm going to get 15. My outer is negative 20i. My inner is negative 6i. And my last is plus 8i squared. And then on the bottom, I get 9. But my outer and inner are negative 12i and plus 12i. So those go away. And my last is negative 16i squared. So remember, whenever you see an I squared, that's going to be negative 1. So you're going to get 15 minus 26i, and then you're going to have minus 8. And you're going to have 9, and then negative 16 times negative 1 is going to be plus 16. So we get 7 minus 26i all over 25. So your final answer is 7 over 25 minus 26 over 25i.
So 0.28.
No, we don't want decimals. No. Decimals are not exact answers. All right, so if you see something like this, 5 plus 2i raised to the negative 1. Right, we know a negative exponent means 1 over, so this is going to be 1 over 5 plus 2i. So again, we have an I in the denominator, so we can't have that. So we're going to multiply by the conjugate. So we're going to have 5 minus 2i, 5 minus 2i. So you get 5 minus 2i all over 25. Outer and inner cancel, so minus 4i squared. So we have 5 minus 2i over 25 plus 4, so 29. So our answer is 5 over 29 minus 2 over 29i.
Will you ever get a different denominator for a and b?
No. Well, if something reduces, I guess you could. All right, next up. So I'm going to do 2 minus 5i, 2 minus 5i. So you're going to try it along with me. Give you your final answer. So you should have negative 8 over 29 minus 9 over 29i.
Can you make that positive? They're both can you wrap positive?
No, because that changes the number. You can't do that. All right, so it says we can simplify I raised to higher power. So we've done this before too. So if you have like I to the 4th, we know that's 1. If we have I to the 2nd, we know it's negative 1. So the key to these problems is to think about how many times 1 or I to the 4th goes into it. Okay? So if I have I to the 15, I want to think about how many times 4 goes into 15. 4 goes into 15, how many times? 3. How many are left over? 3. So what really happens is the I to the 4th to the 3, that's just 1 cubed. It's still 1. So that goes away. So you're really just thinking about the remainder when you divide by 4. Okay, your remainder is 3. So what is I cubed then?
Negative I.
Right, it's negative I because it's I squared times I, and I squared was negative 1, so I get negative I. Okay, so you always want to simplify all the way down. So do the
first equation.
Where did I get what? I just think about how many times 4 goes into 15. So if I divide 4 into 15, what do I get? 3. Remainder 3. So 4 goes in 3 times. You have a 3 left. Because I to the 4th is 1. So it makes it really easy. All right, so I to the 63. So how many times does 4 go into 63? Anybody know? 15 times, right? So it goes in 15 times. So I to the 4th goes into 63 15 times. That makes 60 of the i's. How many more i's do I have? 3. It's not always I cubed at the end. So that means that it's really equivalent to I cubed. But I cubed, we don't leave it like I cubed. We always try to go down to just a plain I or a 1 or a -1 or a negative I. So something like that. So what am I at?
Negative I.
Negative I. We just did that.
What happens when you trade an I for an I? You're both negative an I.
All right, next up. So -4 times I to the 10. What is I to the 10? Yeah?
I'm confused about number 2.
Okay, what are you confused about?
All of it.
Okay. How many times does 4 go into 63? So if you need to do that off to the side. So there's a remainder of 3. So it goes in 15 times, right? So we do I to the 4th 15 times. It's like writing it out like this. I to the 4th times I to the 4th times I to the 4th. But we don't like to do that. We don't want to write it out 15 times. This is 1, this is 1, this is 1. All of them go away anyway. Okay? All right, so what about the I to the 10th? So how many times does 4 go into 10?
2.
2. How many do I have left over?
2.
2.
So you have -1.
Yep, so really the I to the 4th squared doesn't matter. Once you find how many times it goes in, it doesn't matter. You're just looking at the remainder. There's 2 left, right?
Sometimes you
So I squared is -1. So I have -4 times -1, so I get +4 as my answer.
don't say earlier when I said like 7 or 65, I did not look at the next page. I just said that like
Is that the last one? All right.
I like the